Hello? Okay. So here we have two great players from the zk space, Marcin and Jordi. Maybe you can start by introducing yourselves.
Hi, I'm Marcin. I'm working for Matter Labs. We're working on ZK Sync and other ZK technologies.
Yeah. Hello. Hello. Hello.
You have to turn it on.
I have turned it off. Yeah. Hello. Yes. Well, I'm Jordi Bailina. I'm the technical lead at the Polygon zkVM and Polygon co-founder. Yeah, we're building the zkVM. We're building the ACK layer in Polygon, and we are doing a lot of ZK also in Polygon. Yeah.
Okay, and I'm Danilo, previously co-founder at Kakarot, currently building Zap. So we'll start with a little bit. Now we have a history in ZK. Like 2 years ago, ZK was very new. Now we have 2 years of history. So we start some questions about the history. Then we go, what's going on? And then later, like, OK, what's the next steps? So looking back 2 years from today, ZK have been one of the fastest moving technology, even comparing with AI. What do you think was the major breakthroughs that allow us to be where we are today?
So one thing I would say is that first, we should think about how much we did over the last 2 years. We in this community tend to forget about the past. We're always thinking about the next cool thing. But if you think about like 2 years ago, people were saying like, hey, ZK proofs will take years, 10 years, 15 years to do. Ethereum fees were in dozens of dollars, the same thing for the ZK L2s. And look now we're like in cents, sub-cents. How did we do it? By a combination of dozen, maybe even more than a dozen, small improvements coming from different places. The fact that this research was done so much in the open actually allowed us to get where we are. And thanks to Jordi, of course.
You know, I agree. I would highlight a couple of things. One's more visible and one that's probably less visible in the last 2 years. One, of course, is the scalability in general. I mean, right now, building proofs, really complex proof in seconds is feasible. I mean, and this is the reality that we have. And I mean, we'll talk maybe later, but things like SP1 or RE0, we are seeing even that even the way of writing provers is getting even more simple on that. But there is another, probably more hidden thing that happened in the last 2 years that's more, I would say, a maturity in security. I mean, in the last 2 years, we understand much better how to build these proofs, what are the things that can go wrong, what are the security issues that can happen, even how can affect these security issues. So the knowledge that we collect in these last 2 years, running the zkVM, having a permanently open bug bounty on there, having engineers looking at the code, rebuilding, checking. The deepness of understanding on this, I think this has matured a lot. Can we say that this technology is absolutely safe? I mean, you never can say that of any technology, but what I can tell you is that the confidence that we are getting on this technology from the security perspective is every time higher. And I would say that this is one of the things that I would say. And that doesn't guarantee that the code is free of bugs and all that, but that's the feeling, and this is a clear fact that happens in the last 2 years.
Yes, but one thing that did not happen, and this is actually the disappointment that I'm seeing, is that a lot of people still treating ZK as magic. They do not know what ZK means. They are lacking the ZK intuition. And I'm not talking about them coming up here and discussing with us the exact details of Stark versus Snarks, but more like understanding if someone comes to me and says, I'm going to solve it with ZK, Does it even make sense?
Yeah, probably the magic, when we say that the ZK, the magic part of the ZK is actually the zero knowledge, but it's probably the part that we are not using in a normal roll-up. I mean, that's more that comes more from the privacy. I mean, being able to prove a computation, but without having to reveal the input of this computation, I think this is more magic than just proving a computation. Because proving a computation at the end, there is a very easy way to verify. You just run the computation again, and this runs. So the only thing that we are doing here is that instead you to have to run everything again, you just get this cryptographic proof to do the equivalent to that. So intuitively, it's not that different. Okay? I think it's more magic when we are talking about privacy, when you are hiding these inputs here. But yeah, I get your point. I mean, I would say that the problem is that, and this is we have seen that, is that people just trust in the tech, and in the ZK but I would say that ZK is not an exception here. I mean, we have seen how many people just verify smart contracts and check the smart contracts. We just trust Etherscan that they are verifying the right way, but do we know if Etherscan is doing well? I'm not saying they're not, but we should verify more. I mean, we should check more. We should check more on the technology. We should check more on how the things are done. And I agree. I mean, we see a lack of understanding of developers and people getting more depth in this tech to understand this tech. But again, I mean, there is something.
Yeah, because for me, it's one part is the laziness, what you mentioned with Etherscan. This is like our laziness as developers. We got fat and lazy. Originally, Ethereum blockchain was supposed to be the thing that, against decentralization, against this, assuming that everybody around you is malicious. And we got lazy.
Let me explain you one story. So when we deploy the smart contracts, actually the verification of the smart contracts for the ZKVM, we publish kind of instructions in how to verify the verifier. I mean, how we can check that the verifier actually, there is this source code that's open, you have a commit hash, and from this commit hash, you go to this verifier, and you have all the source here. Okay? And, I mean, this verification process was not, it was relatively complex, because, you need a big machine, and requires some time, and some skills, but, there was a full process there. Okay? In this script, there was a bug. There was a bug, there was like something that was wrong. So it was impossible to verify with the script we verified. Nobody told us, I think it was like after 3 months or 4 months on that. For me, that was really frustrating when on that, because do we really have a community that we just deploy these smart contracts? Probably, and these verifiers, probably one of the most complex things, and nobody just even verify that? Just let it here.
Yeah, I agree. And I think looking back to ZK, like it shows the power of also decentralization and the Web3 space. This progress wouldn't have possible if it not in the Web3 context where open sourceness and community is so important. I think like if it was in the normal standard market, it would take a lot more time to go from where we were to where we are. Okay, going to the next question. Okay, looking now back at the journey. So Polygon had the Polygon Hermes ZK VM, and then had the CDK, and today you have the Ag layer. The ZK Sync team had the ZK Sync era, the ZK Stack, and today the Elastic Chains. I see that your journey has been very complementary, and maybe could you, Jordi, maybe you can talk a little bit about Ag layer, and then Marcin, you can talk about the Elastic Chain, and so we can have some comparison and some differences in this.
Yeah, I think that there is no many differences, but The idea here of the AG layer is to have a set of sovereign chains. I mean, chains that can be very different in essence. I mean, they have they may have different tokens. They may be validiums or ZKVMs. They may have a centralized sequencer or a decentralized sequencer. I mean, they may even have a different state transition function. I mean, it can be even, maybe one is maybe a EVM, the other could be maybe a ZK WASM or a Maiden or something that's an app chain with some specific state transition function on there. So they can be very independent, very sovereign, each one. And the idea is that these chains, they can communicate one each other, that value can be transferred in one each other with the less friction for the user perspective. And here we are talking that the idea of that layer is to be, we'll see what's going to be the level, but the idea is to be very few seconds for transferring value in a committed way, I mean in a safe way and trustless way between the different chains. And that's very much that. Of course, should be open for the people to deploy these chains. And this, I mean, this is the horizontal scaling. I mean, when we were building the ZKVM, we were thinking about the vertical scaling. I mean, just having like a fast processor, high frequency, and trying to be as fast as we can. And here is more about having like a network of processors, but different processors. I mean, different networks, different sieves, with different rules, with different governance rules in each one, and connecting all them together. And this is very much the AG layer, and this is what we are building right now.
Right, because the way you can think about it is the more progress there is in ZK, it kind of uncovers more and more use cases. Like what Jordi was saying, the fact that suddenly we can do a proof in a couple seconds rather than a couple hours allows you to do these fast interrupts. The fact that you can use things like SP1 to prove the risk instruction set, means that you can suddenly have far more flexible STMs. So both of the companies are approaching this from a little bit different angle. The first approximation, and some of the BD people will kill me for this, is the same thing. The same way how you have like diesel and gas engines. For the first approximation, it's like, it's an engine, it goes. Of course, the more deeper you go, we differ a little bit in the approaches on like what we prioritize, which path we selected towards this. But the ultimate thing is that you are able to have far more flexibility than what today Ethereum gives you, because Ethereum kind of allows you a lot, but forces you into this EVM transition function, forces you into Ethereum behavior. This opens up the whole new possibilities, but with this, the whole new set of risks. That's kind of coming back to our discussion a couple of minutes ago about people not understanding what is within the ZK shield and what's outside. Because the thing that scares me, actually, and this is one of the nightmares, is that people will think that, yes, I am launching on-chain foo because it's under ZK, I'm super safe. And then they're going to get rug pulled. And then there will be a huge storm of, but wait, I thought this was under ZK, why didn't it work? Yeah, because ZK only covered this and you didn't cover, that's the risk that we have. So I repeat, the thing for all of you folks here is with what we're building, with AG layer, with Elastic Chain, will open up a world with new possibilities. But please, do your research. Do not be lazy.
Yeah, I wanted to ask a question, like now looking at the future as, let's say, like AG layer gets established and there's a lot of chains and then Elastic chains also get established. I feel like, is this going to be, just like today we have two chains, is it going to be like still two different ecosystems? Or do you think later on there's going to be some kind of interaction between these ecosystems? Because as of now, like we could say, let's say each chain is a dApp. It would, if we just go the way we are, it would still be like just two ecosystems. Do you think that the future is interoperability between an ecosystem, or even a one level higher of an ecosystem that will put AG layers and CDK apps together? I'm just curious on what are your thoughts on what would come?
Yeah, my thoughts is maybe not two, maybe 3, 4, 5. I mean, we are seeing that these kind of constellations are happening. We will see how many. It's clear that I mean, I'm not sure because, so I'm not sure if there is a space for thousands, okay? But a small, I mean, a small set probably, yes. And the question would be is what's the friction between this interconstellation or so if somebody wants to transfer funds from one chain in the CDK to one chain of the elastic chains of zk, what's going to be the friction for that? And I would say the answer here is Ethereum. The common root is Ethereum. So here, for reducing this friction, we probably here will need the help of the L1 Ethereum. We will have to go through L1. It can be an aggregated. It can be an aggregated transaction. It's something that can be consolidated quite fast. But from the user perspective, I mean, the problem in Ethereum is that the finality in Ethereum is a couple of eras. That can be 12 minutes or something like that. And 12 minutes for a user is a lot. I know that in the EF there is a lot of research for trying to lower these numbers. And I think this is fundamental, or it's going to be fundamental in the future, especially for these let's say, interconstellation transfers on that.
So I would say that first, remember that when we're talking about the ZK, it's not only two of us or two of our companies, right? This is the ecosystem. This is the community, and the community is not just an empty word. The thing that I predict is that when there is a need, people will find a way. And usually, with all the interops, with all the bridges, it's a trade-off between what's your latency, what's your security, what are the risks. Now, our role is to just bring the overall, like, this Pareto frontier, like, down, meaning finding even cheaper, even faster. But it will always be this trade-off. Because even if it's 1 second, someone will be like, Jordi, but I want a 100 millisecond one. That might be insecure, but I want it faster, right? So there's always will be these corner cases.
And it's important that there is many projects trying that. I mean, this SAG layer is not an easy project, and it's very tricky. And when you think deep about that, I mean, there are some implications. So, and there is different path to build that. We've seen that, for example, when we're talking, I mean, there is different words here. I mean, we're talking about shared sequencers, and we're talking, but at the end, we are talking about this interchain communication somehow. And there is a lot of options, synchronous versus asynchronous, using ZK, not using ZK. I mean, there is a lot of variables and ways to do that. So having different teams, trying different approaches, the ones that are doing better, I think this is great for the space. Because the same that with the ZKVM, I mean, we learn one each other. We learn a lot from ZKSync. We learn a lot from Scroll. We learn a lot from StarNet. I mean, each of these networks, they are adding some value in something. You will take it, and sometimes the value is the mistakes that they are doing. I mean, it's like this, you cannot do that way, but that's okay. I mean, that's the learnings. There are good things, bad things. You see what's going on, you improve your system, and you're just trying to improve yours. Sometimes it's new ideas that comes from yourselves, sometimes are good ideas that come from the others. And this is the way to grow the ecosystem. So that's why it's important that there is a set of projects trying this. This is a new thing. I mean, we haven't built that before. It's something that the humanity haven't done that. I mean, and we have the ZK. The ZK tech is quite new now. Again, I mean, I think it's fundamental, but for this, the role of the ZK proof for this interchain communication somehow is fundamental and key. The fact that in the ZK you can prove something immediate. I mean, you just generate the proof and this is a proof. You don't need to wait for some gaming timeout or something else. This is at the moment that you are transferring funds, sending something to the other network, being able to prove that I'm here, I'm committed, it's correct, go ahead, use it. This ZK is fundamental piece. But I mean, it's available since few months.
Yeah, I agree. Like, I think this diversity makes the ecosystem more resilient. Just like we need a lot of different implementations of the Ethereum node, I think all this, it's important to have different teams, great teams implementing different. So, and then talking about resilience, what do you think, like, today, we haven't found any big bug or anyone wasn't able to, like, hack it or like, do a big hack. But I feel like this is, if time was infinite, this is inevitable. Like, at some point, it might happen. There's a probability to happen. Is there, like, how would that look like from your thoughts? And today, is there a measure? So if that happened, we have like a countermeasure for it? Or is it something that, because it never happened, it's hard to predict?
How to say it? The way I would compare it is like, you know, in 1905, when they pushed out the first car going 5 kilometers per hour, there were no car accidents. So they could assume that there will never be car accidents, right? How they solve it with cars? They started putting security measures, airbags, seat belts, whatnot. And a similar thing will be happening to ZK. I'm very happy that you're so optimistic about the amount of bugs that exist in ZK. I'm less, but...
No, but I mean, the last 2 years we found many bugs. I mean, it's not something. No, it's no. We found many bugs. I mean, the thing is that we are responsible, because I mean, and I think I'm talking also in the name of ZK and all the ZK projects. I mean, I think that we have been very responsible in the security. We have running a lot of audits. We have running all these trailing wheels with some setups. For example, one of the things that give us a lot of warranties is that we have a centralized provers. I mean, we are running the prover. This is not a big thing, because at the end of prover you cannot do much. I mean, you either can prove or not. Okay, and actually in the smart contracts, if we don't prove, anybody should be able to prove. And so the prover, being centralized prover here is not a big. It's much worse than centralized sequencer. I mean, that's the biggest divide. But this GAFAs, from the security perspective, makes a lot of difference, because these, for example, all the soundness errors, I mean, in the case of a soundness error, I mean, you cannot exploit. That doesn't mean that we are not assuming security risk with that, because here it's important to mention that, for example, when there is a soundness, we have an internal risk. So well, what happened with the developer that has the private keys that's sending the proof, if they can exploit to that. So, I mean, it's really important. I mean, having a soundness-free ZK is important, but I mean, here the training wheels, this some sort of centralization that we have been applying in these networks has been fundamental for not having to explain a disaster or something bad. But there is a lot of evolution, as I said at the beginning. I mean, one of the big improvements in the last 2 years is the confidence that we, from the security perspective, we have in the system.
So one thing I would add is that the more companies we have working on ZK, this also gives additional security things, because we can as well easily say, like, okay, in order to proceed, you have to provide 2 ZK proofs from 2 different provers, right? So this slowly and steadily adds these security. Or, you know, from the panel before, I don't know who won, TE or FHE, but like all of these systems are also providing these additional security guarantees. The same way how you would put 2 or maybe 3 locks on your doors. Even if you think that one lock should be enough, you're going to add the additional 2 just in case. The same thing here, really depending on the amount of security you want to have in your doors or in your systems.
Thank you. I think now we can go to talk a little bit more about the future of where do we think ZK can be in a few years. And from your perspectives, what is missing from here, the next 10x, 20x breakthrough? Like, how can we get even faster? So we got, I think, maybe 100x improvement, or like a lot of x improvement since 2 years ago. Like, and I think a lot of that came from research. Do you think research is still, there's a lot to be done, or there's more?
Yeah, here, of course, this is the future. Here we are just taking our crystal ball and just talking, okay? But here what I would say is that, at least in the Starks is the most used, I mean, it's the fastest technology. I think that most of the projects are migrating to that somehow. But the Starks, we are touching a little bit the limit of the Stark. And this is very much because at the end the Starks are based in hash functions. And I mean, hash functions are quite well optimized. And the minimum thing that you can do in a witness is running a hash function, which is actually more or less what you are doing in a Stark. I mean, you are doing an NTT2, but that's so we are touching. I would say we are touching the limit very much here. I think that from the research perspective, I mean, from new things that are happening, I mean, so for example, some GKR in some parts of the Stark or the VNews, or I mean, there are some new techniques for some papers that allows us to maybe, and here maybe we can get one order of magnitude, but I don't think that we can get much more unless there is some huge breakthrough in the tech that never happen. But I don't think that using this current tech, we can get much more than one order of magnitude. Where we can get two orders of magnitude on top of that is in the hardware acceleration. And this is, I think, this is the phase that we are entering right now. We know that there is different projects that are currently developing ASICs and FPGAs and different hardware solutions for building ZK. And here, talking about at least one order of magnitude, and I would say reasonably talking two orders of magnitudes on top of what we have, this is perfectly doable. And again, and this piece is fundamental for this aggregation layers thing, because this can accelerate a lot, and that what can give this latency. Until now, the ZKs, we haven't been optimizing the proof generation for latency. I mean, we have been optimizing for throughput, or if you want, for cost. I mean, it's how much the proof costs. I don't care if I take it more, but the cost at the end, the total cost, the total dollars per proof is lower. But when you are optimizing the latency, okay, I'm willing to pay a little bit more, but I want the proof to be fast. I mean, I want to do the proof in 1 second or in 2 seconds. Here is where hardware acceleration makes a lot of difference. This is going to be fundamental in the upcoming months, years, and I think this is going to be the big thing that will happen in the next month, years.
So yeah, the one thing I would add to this is, look folks, what you're hearing basically is that this will cost almost the same as CPU, so you'll be able to ZK proof whatever you want. So now this is up to you. Again, I'm kind of repeating what I said before. To get this ZK intuition, to understand what are the new cases that you can apply the zero knowledge for. As Jordi mentioned before, this is also part of my disappointment, is that we're not using the zero knowledge part of the zero knowledge. We call it zero knowledge for a reason. And here we are hoping that some of you, maybe after this panel, will be like, maybe I should do something about that. I should do it to introduce maybe a little bit of privacy, maybe a little bit of this.
Yeah, I remember that at the beginning, I mean, just maybe 3-4 years ago, there was a debate if we should keep using the term ZK or change it, or just finding a new term for that. We already decided to go for ZK because actually it's the tech, it's the naming that we have been using on that. But it's also worthy to mention this, because ZK, and this is very related to privacy, and I think this is really important to mention, and I agree that using ZK for privacy is also important.
Yes, I think we are out of time.
So get off your phones, learn about ZK, and start using it in your next project. Thank you.
Yes. Thank you, Jordi. Thank you, Marcin.